All of 8, yeah.
All of 8.
And is the test still going to be on December 3rd, or are you going to move back?
No, it's still on December 3rd.
You should move it back.
All right, so 10-1 I'm not going to spend a lot of time on, but I do want to make sure that everybody remembers this. 10-1 should be insanely nice. 10-2 is just a little bit harder, and then 10-3, I think there are a few people that hadn't really used many matrices before. So for you guys, it will be a bit of a catch up to see how it works. Yeah. Yeah. Sure. All right. You can see why I'm not going to spend a lot of time on this. This should be... So the first method of doing this, really the first method is graphically. So if I graph both of these, solve for y, get mx plus b form, plot them, the answer is of course going to be where they meet. We've seen that before. We've used it for more complicated equations. Seeing where they meet to solve equations. Not a big deal. The second method is substitution method, which is exactly as it says. X is y minus 2. In a system of equations, these both have to be true. So I can use either one of them in the other one. So I can replace this x with y minus 2. So effectively, I've subtly changed it. I've killed a letter indirectly by replacing it with another letter. So I always think about Invasion of the Body Snatchers kind of thing. Right? But less evil looking pies. Here, so you get -4 equals 2y, you get y equals -2. I think, or is it just 2? 2.
Just 2.
-2y equals m.
X is
Y is 2, and then you've got x equals y minus 2, so x equals 0. So the answer is 0, 2. It's the point where they would meet.
Is that -4 or -y?
-4. Sorry. Subtract 6. Y minus 3y is -2y. Why did I switch it? I don't know. My head decided to do that. But this is not a big deal, right? Please do not. This should be nothing. That's all I'm talking about. Then we have elimination.
That was a substitution.
Yeah, first was substitution. Then you get elimination. So what's the main thing with the elimination method?
Like similar.
You want to cross off?
Yeah, I need coefficients to be same but opposite sign. So then I can, this is very subtle. It subtly replaces a variable with another one, so I get an equation with just one variable. This one's much more direct. It actually goes and kills one of the variables directly. Right, so it's two very different ways to govern the country, for example. But obviously, if I add them together right now, I don't get much of anything. Now, this is where I can, let's do this directly, and then I'll show you something where you can be very smart about this. What would I have to do to get this to work? Yeah, you could do 3 and 7, or you could do 4 and 5, right? To make them the same. It's exactly the same idea as LCD, right? Same thing. So if this was a 6 and a 4, it would be 12 LCD. I multiply this by 2 and this by 3. Right? Same idea. So here I multiply by 4. Here I multiply by 5. So you get 20x minus 28y equals 44. There you get -20x plus 15y equals 25. I did not make this to come out nice, by the way. I didn't even consider anything at all while I did this. The only possible way they can make this anywhere near ugly is to have fractional answers, but if that troubles you, oh well. So here you divide by negative 13. Fine. What's that? 5. No, 5 would be 65. So this won't go in even. Right. So how do you get x? You just plug y back in. So you know what's up? I plug it back in here. 5x minus 7 times negative 69 over 13 equals 11. So you get 5x equals what is 7? 490 minus 483. 483. So x equals that crap divided by 5. I mean, that's nothing major, right? Yeah.
The point you get is where the two graphs meet.
The point that you get would be where these two lines would meet. Exactly. And any equations I plug in here would be where those two equations meet.
No matter how many there are.
Yeah. So when we do something like so this would be 11 minus 483 over 13 over 5. You can clean it up however you want to. There was a problem. Remember a while back it was like tangent inverse of 1 over x equals cosine of 4x. I can't remember. You had to find the answers. So sort of like I did y equals tangent inverse of x, 1 over x. Y equals cosine of 4x. So then I substituted. So of course it's going to be where these two equations meet is going to be the answer. So we're really right there. We used graphical method to solve those equations. Okay. So again, the only thing they could do to you is put fractions in there, but give me a break. That's what I want. That's the hardest part of a problem would be fractions, and I'm like, yes. Let's see, nothing major in there, blah, blah, blah. Okay. So 10-1 should be fantastic. Then we get 10-2, which is a little bit harder. Let me see how many of you guys remember how to do this. You're not allowed to use matrices yet in 10-2. If you know matrices, I don't want to see any of them in 10-2. All right? So this would be a problem like well, let's see. I gotta know the answer for you. See if that works. Say again? I'll show you. Way after we do matrix. Not way after. I'll show you how to do it. So here I have 1, 2, 3. So anytime I have n variables, I must at the same time have n equations to fully solve this. The minute that I am missing an equation, or if one of my equations like cancels out, like if this third one was actually this one plus this one, which I'm hoping it is. No. Is it equal to? Oh, it might be. Shit. Oh. We'll see what happens. If I ever lose one of them, then I'm not going to be able to fully solve the system, right? You guys kind of follow what I'm saying. So if I had, for example, if I had x plus y equals 4 and 2x plus 2y equals 8, I can't fully solve that because they're both the same equation. So I end up with x plus y equals 4. That's the most I know. You guys kind of with me? Because these would cancel out to 0 equals 0. Students would write infinite number solutions. We're going to be a little bit smarter than that. We're going to say y equals 4 minus x. So if x is t, y is 4 minus t. Oh, shit. So that's the complete system of, the complete set of answers. Whatever I make x, y just has to be 4 minus that, and that would be an answer. Okay. Just in case something happens here. Who remembers how to solve this by hand?
We did a calculator in my last class.
I got you. That's sucks.
Don't you solve
I
two,
don't know what they
and then you
call
solve the
it.
other two?
Exactly.
and then
So
get the-
you eliminate a variable. Here, what did I do here? We eliminated one variable once, and then I ended up with an equation with just a single variable in it.
Yeah,
Right?
it's easier way.
Yeah. The easier way is called using a matrix, and the ultimate easiest way is plugging in your calculator in matrix form. But going true to form here, we always learn the true what the hell's going on. We don't rely on technology to do everything for us. So what I do is, if you pick a variable, what variable? Let's just stick with x. Doesn't really matter. If I add 1 and 3, x goes away, right? So I add 1 and 3, I get negative y minus z equals negative 7. Is that cool? What's the matter? Add 1 and 3. X minus x is 0. Negative 4y plus 3y is negative y. Z minus 2z is negative z. 7 minus 14 is negative 7. So why did I pick that? Because I could see the x's would go away. Now, is there any other way to make x go away directly? Not as it's written, right? How can I make x go away again? I could take 2 plus, not 3, but plus twice 3. Then that would cancel out, wouldn't it? 2 plus twice 3. So here's 2. And here's twice 3. How we doing? Good? This should feel familiar, hopefully. Tell yourself what the hell's going on. In fact, I have my students call this one equation 4. Are these equations like gone once I add them together and stuff? No, they're all still here. It's just that this is also an equation that's true at the same time. If x minus 4y plus z must be 7, then negative y minus z must be negative 7. I realize this is true, putting all these together. What do I get here? Minus 5z equals negative 13. Cool. 23. Thank you. Of course I make that mistake. So I would call this equation number 5, amazingly enough. You could call it equation 13 out here, as long as it's some new equation. So I have equation 4 is negative y, let's just be straight, y plus z equals 7. Is that cool? Just kill the negatives all the way through. And equation 5 is 7y minus 5z equals negative 23. Yeah, that makes sense, okay. So now I'm back in the same situation I was just a minute ago. I've killed one variable twice. So I end up with 2 equations, 2 unknowns. We just did one like this. I can take this one and multiply by 5. So I get 5y minus 5z equals 35. Then if I add those together, I get 12y. Why did I do that? Plus, Jeff. So multiply this by 5, 5y, 5z, 35. Negative 5 and 5 is 0. Negative 23 and 35 is 12. So I get y is 1. Then it's dominoes. It falls back. Y equals 1. I fall back once here. I can figure out what z is. Once I get z, I fall back one more time. I use any of these to figure out what x is. So y is 1. This one tells me that z is 6. And then if I use, for example, number 1, x minus 4 times y plus z equals 7, so x equals 5. So what's the point? Yeah, 5, 1, 6. So that's a point, three-dimensional space. This is actually 3 planes, and that we just figured out is the point where they meet. You guys with me? Sort of? So that's the geometrical interpretation. So I go from lines meeting, the minute I go into three-dimensional space, now I've got planes meeting, and it's really like, this is one plane, this wall is one plane, that wall is another plane, and the ceiling is another plane. Where do they all meet? That point right there. So we just figured out that point right there. Do they always have to meet? Hell no. You can have planes that are staring at each other forever. Right? They won't meet. I could have 2 planes that meet, and the third plane doesn't meet at the same place. So this could come out with no solutions at all. Or it could come out with an infinite number of solutions. Because one plane might hit another plane and another plane, and they hit in a line, and that would be an infinite number of answers, for example. You guys semi with me? All right. So, section 10.2. In fact, page 643, they actually show you the pictures of what I was trying to represent in the air. Page 643. The first one is like the walls in the room that meet in the point. The second one looks like a Rolodex, right? They meet at a line, so you'd end up with an infinite number of answers. And the last one is there's no answers. They don't all meet somewhere. So the last one has no solution. How would you tell it has no solution? What would probably happen? As you do this, you would get something like 0 equals 7. So the math is saying, all right, dude, if 0 is 7, your stuff is good. Oh, thanks, man. My stuff sucks. So that's why that happens. Yeah.
Would you ask me from the test calculated by hand? Would you ask me from the test calculated by hand and not in matrices?
What do you think? I would only do a 3 by 3. You can imagine. You guys see why I call this 3 by 3? When it's actually more than that. If any of you know matrices, it's like 3 by 4. But I call it 3 by 3 because there's 3 equations by 3 unknowns. So can you imagine an 8 by 8? Doing that by hand. Like, so the thing I try to help people, those of you who've gone through the matrix stuff before, when I say that you've gone through the matrix stuff, have you used it to solve equations like this?
Yes.
A few of you have. How many of you haven't? Okay. For a 3 by 3, this wasn't that long really, and it's relatively easy. But the minute I have a 4 by 4, can you see how the work is more than doubled, really? So 5 by 5, 6 by 6, it's going up exponentially as I go along. But a matrix, the work with a matrix barely increases as I make this larger. So if you learn how to solve this with a matrix, you can solve a 20 by 20. Not as quickly, but not twice as long. It'll be really quick.
And without matrices, if you mess up in the beginning, like minus or something, then your whole work for the rest of your problem is kind of like.
Well, same thing happens with a matrix, though, man. That's the easiest. If we get a negative somewhere in one little place in a matrix, the whole thing goes to
shit.
shit.
With a matrix, you just, come back, clear, send back.
Oh, you're thinking, yeah. You're not remembering that you're in my class, where we'll first do them by hand. What? I did not realize that, John. Okay. So let me give you one to try here on your own real quick. Let's see if I can give you one that's Look at number 25, page 647. With the booklets amongst us, here we go. this one, part of the work has been done for you already. You notice a couple of them are in missing variables, so you just have to make that same variable disappear again. One more time, instead of twice. A few different ways you can do this one. So if I look at number 1 and I see that it's missing an x, if between these two I can make x go away again, I've got two equations with y and z. I can go from there, right? Or you can do the same thing with number 2, it's missing a z. If I can make a z disappear again, I'll have two equations with x and y. It doesn't really matter. Those are two main ways, and there's a third way that's even more interesting that we'll do in a minute. So if I do leave this one alone, how can I kill x between these two? 2 plus twice 3, right? Here's 2. There's twice 3. So what do I get? Negative y plus 2z equals 0. Now, of course, you realize once you bring this down, here's number 1, here's number 4. When I add those together, I get
0, 0.
Yeah, I get 0 equals 0, which tells me what? It's an infinite number solution, so you can't stop there, though. Right? I definitely don't want to see anybody write all real numbers, because the answers are points, for one thing, right? Infinite number of answers is better, but it's not yet complete. You've got to give me all what the answers are. So I know that y is twice z. I know that, let's see, what's an easy one? Number 3, maybe number 2, right? Let's see, there's a few different ways I can go with this. I know that x is 2 minus 3y over 2. Could you guys see that? From number 2? Just subtract the 3y, divide by the 2. How are we doing so far? So x is that, y is that. So what's x then, really? 2 minus 6z over 2. Which is 1 minus 3z. So x is 1 minus 3z. Y is 2z. How we doing? See, what I'm trying to do though is I want to base it on everything on that last variable. Z is Z. It can be whatever the hell it wants to be. Now this next step is seems a little bit arbitrary, but it's just the way we do this. We say Z is actually T, which means Y is 2T, which means X is 1 minus 3T. What that really does for us is it really hammers home that this whole thing is dependent on just one parameter, one variable. So this would be a situation where all three of these planes hit in a single line. I don't know it's a single line because it only takes one variable to describe it. So that would be one-dimensional. If it took a T and an S to describe it, that would be two-dimensional. That would be a plane. Okay, that's kind of going further than we really need to, but that's the whole idea. So this would be the actual answer to this equation, this set of parametric equations.
What is that? Z equals T?
Yeah, Z equals Z was from this. So Z equals T to start that thing off. If Z is T, then Y is twice T, and X is 1 minus 3T. So really, to make this truly in the right form, the answer would be 2T. You can do it, Jeff. 1 minus 3T, 2T, T. Right, X, Y, Z. That's the one extra step that's on top of this that you didn't do back in algebra, more than likely. I doubt that a teacher really made you do that. But whenever you get that 0 equals 0, you start putting it in terms of the Y equals 2Z here. So Z is going to be a natural choice for T. Z doesn't always have to be T. Z was my natural choice for T because Y is twice Z, X is 1 minus 3Z. Everything's dependent on Z. Cool, so I'll let Z be T. Then everybody else is dependent on that one thing. Okay. Yes, sir?
How did you get 2 minus 3y?
From here. So subtract 3y, divide by 2. Is that cool? You could go from number 3, add the x over, add the 1 over. So from number 3 you would get x is negative 2y plus z plus 1. Right? But then y is 2z. So you'll still end up with x equals to negative 3z plus 1. Same thing. So you almost can't go wrong there. So that's the one thing I think that could certainly give us a little bit of trouble here, is getting used to how to represent the answer when there's an infinite number of solutions. It's not good enough anymore to just say infinite number of solutions. You got to tell me what do they look like. Got to be a little more precise. Cool. Okay. You want to take a break?
Yeah.
Yeah? So be back 20 after.
Are we gonna stay in 10 today, or are we gonna move on?
What's that?
Are we gonna move on past 10 today?
Oh, hell no. We're not going to be past 10.
Oh, we still.
I'm hoping to get one section left to do for next time out of 10. Yeah. Because next thing we're doing is matrices, and if I get through that today, that's plenty.